Okay, so we were talking about this graph that we drew, right? And I told you you can use Excel to make scatter plots, and I'll also show you how to use your calculator to make it, because sometimes it's not, I'm not going to have you draw them by hand, you know what I mean? So you can put the data in L1 and L2 and then run the appropriate tests, but if it's already in there, you can look at a scatter plot, okay? So we're talking about, for the descriptive statistics, to use LIDS, remember? L stands for linear, I stands for influential points, D stands for direction, and S stands for strength. Okay, so we were talking about, is this linear? Yes, it appears to have a linear relationship, right? Then influential points, I told you the way I remember them was, do any of them look like an outlier? You know, drastically different from the rest. They're still kind of in line with it though, right? If I were to create a line of best fit. They're still kind of in line with it, right? So last year when you had Miss Whitaker, she would have actually showed you how to create a line of best fit and how to see how far away they are. It actually creates little squares. So the formula uses the sum of the squares, and you try to get those squares as small as possible. I don't know if you remember that from last year, and it's okay if you don't. But when it's a really big square, that's an influential point because it's so far away from the line. And it actually pulls the line away from the other data. So if you were to remove it, it would have a better fit, the line would, okay? So any influential points, I said no. They all appear to be close to one another, right? Direction. So that's asking if it's positive or negative. Read a graph from left to right. It's going down, so it's negative. Good. And then the strength, we actually have to run the test first to get the strength, okay? Or find the linear regression equation. So to get the strength, that is your R value, okay? So to get the R value in your calculator, we talked about this other day, you have to hit second and then 0. So you hit the second button and then 0. And that is your catalog, okay? So that catalogs everything your calculator will do. And you're going to arrow down until you see diagnostic on. And then you press enter, and it moves it to your home screen. And then you press enter again, and it'll say done. I don't know. I don't know why it's not just automatically on. I'm not sure. I will tell you, when you clear your calculator, this goes away. So you have to go back in and turn it back on, okay? That's why I'm writing it down and telling you how to do it, because when you clear your calculator before a quiz or a test, it resets it, okay? Well, if you go to it, you won't be able to see R if you haven't turned it on. So you'll be able to see the equation, the line, but you won't have R, which I hope will make you go, oh yeah, I got to turn it on. So second 0, arrow down to diagnostic on, enter, okay? Say, okay. Do you remember how to turn it on? Come on. Okay.
Maybe sit there for 5 minutes till I figure it out, trying to do everything I can.
I'll just take
No.
a
All right.
Nap.
So R is a unitless measurement between -1 and 1, okay? So if it's negative, that's because the direction is negative. If it's positive, that's because the direction is positive, okay? If it has a -1, that means it perfectly fits. So it's going to be in a perfect straight line, okay? And that means as X increases by 1, it is decreasing by 1. Increase by 1, decrease by 1, or 2 and 2, whatever, okay? Same thing if it's a positive 1. As X increases by 1, Y is increasing by 1, or 2, 2, whatever, okay? So when it has a 1, that means the linear relationship is perfect. It perfectly fits, okay? Any number in between, so if it has a R value of 0, that's horrible. That means the scatter plot would just be dots random everywhere, and you can't even see a pattern at all, okay? So R is unitless. and it will always be between or including -1 and 1, okay? The value of R is the same regardless of which variable is your explanatory variable and which is the response. So if you accidentally put the Y's as your X's or vice versa, you'll still get the same R value because it's measuring the relationship between your X's and Y's. So even if you flip them, it'll still be measuring and you'll get the same value, okay? And then the next thing, the value of R does not change when either variable is converted to different units. So that's kind of interesting. If you were to put it in there as feet and find the R value, and then you change it to inches, like my height and my wingspan, my arms. If I put that in feet, find an R value, then I convert it to inches and find the R value again, it's going to be the exact same number. Because again, it's measuring the relationship between X's and Y's. So even if you convert it to different units, you're still going to get the same R value. Okay? So here's some interpretation guidelines for the correlation coefficient. So that is what R is called. R is called your correlation coefficient. Okay? We said has a weak correlation if you take the absolute value of R and you get a number between 0 or 0.3. Okay? If you get an absolute value of 0.3 or a number between 0.3 and 0.7, we say moderate, okay? And then for strong, take the absolute value of 0.7 up to 1, okay? Now, it says absolute value because if it's negative, it just has a negative correlation. But let's say I got negative 0.287. That's a weak negative correlation, okay? But if I got a value of 0.8826, that would be strong. Now, yesterday's class was asking me, what if we get 0.3 exactly? I said, well, until this year, it's actually really interesting. Until this year, I could never find something in the textbook for how to figure out is it weak, moderate, or strong. So I told them that was 3 options, right? So I just divided it by 3. 1 divided by 3 would be 1/3, right? Well, 1/3 is 0.33. So anything up to 0.1 to 1/3 or 0.333, I said was weak. And then 2/3 is 0.67, which is interesting because that's really close to 7. So I actually classify 0.7 as strong. And the reason I'm telling you that, they said, what do we do if we get exactly 0.7? Well, look, it says absolute value between 0.3 and 0.7. Then this one says between 0.7 and 1. So that's why I'm telling you. If I get 0.7, I'm going to say that's strong. If I get 0.3, I'm going to say that's weak because it's less than 0.3333. Okay? So that's kind of how I did it before I looked this up for y'all that made these note sheets this year. Okay? All right. I'm not going to count it wrong, though. If you get 0.7 and you say moderate, I understand because it's right there in that chart. So I'm not going to count it wrong. I'm going to say 0.7 is strong, though, because I'm kind of stuck on my thirds thing. All right. So how do we do this? Well, we're going to put this data. Here's the data right here. We're going to put this in the calculator, okay? So let me get my calculator. And remember, mine's the free version, so just ignore it, love it through it. All right, let me clear out all this stuff so we can do this together. So what do we put in L1? The X's or the Y's? It actually does not matter with the R value, but it does for your line. X is good. So X is going L1. Thank you. Look at you working that note sheet. So 1,004, 975, 992, 935, 985, and 932. Now arrow over to your L2s. I'm going to put in the Y values. So 40, 100, 65, 145, 80, and 150. So if we hadn't drawn this scatter plot and we wanted to see if it's linear, what you do is you hit second y equals. You make sure the plot is on. You arrow down. The type is the first one. And then look, your x's are in L1, your y's are in L2. Does everybody see that? And then you hit zoom 9. And look, it shows you your scatter plot. I thought it was really interesting because I literally did not type this in the calculator until yesterday when I was teaching it. And they went by 10s on the bottom and they went by 20s on the y, which is exactly what I did. So I just thought that was funny. Okay, questions on how to make the scatter plot? No? Okay. So now that the data is in there and we want to see that R value, we're going to hit Stat. We're going to arrow over to Calc. And we're going to choose option 4, which is our linear regression.
That kind of scared.
I'm sorry.
I was looking at my calculator and then I just heard another voice. And I'm like,
Uh-oh, I should have got out of this first. Okay. So I'm going to click Stat, arrow over to Calc, option 4, and look what it's asking. Are the X's in L1? Yes. Are the Y's in L2? Yes. So then we hit Enter. And you'll see it gives you a B, R squared, and R. Okay? Everybody see that? Okay. In this class, I'm not going to count it wrong if you put AX plus B, but we use the form A plus BX. And the reason I'm trying to get you to do that, let me show you, is because when you use A plus BX, look at what slope is. Slope is B, right? And then I told you when you're writing your hypotheses, you write them about the slope, which is beta. B, right? So parameter of interest would be little b, and then the statistic that we're going to find is B, and then our parameter is beta. So I was trying to be consistent. I'm not going to count it wrong though if you put AX plus B. It's fine. That's because in pre-algebra, algebra 2, pre-calc, we write y equals mx plus b. So you're just used to that, so I'm not going to count it wrong, okay? And obviously, I forgot that my note sheet deleted everything. You have all the other ones, right? The beta's less than 0 would be negative, and then beta does not equal 0. That's just looking to see if there's an association. We're not sure if it's positive or negative. Okay. So back to this. In your calculator, it gives you an equation. I am going to write it in the form A plus BX. So you have to pay attention to which one is the slope and which one's the y-intercept looking at your calculator, okay? So when you look at the calculator, you should get negative 1.4. No. Excuse me. Sorry. I was writing the y-intercept, not the slope. Sorry. So the slope... No, I was writing the slope, not the y-intercept. I'm saying it backwards today. The struggle is real. Let me just write it, and then I'll talk. Good grief. Okay. So if you read that, if you write it in this form, the first one right here, this is your y-intercept. And this one is your slope. Okay? So if you look at that slope is what? Negative. Doesn't it have a negative direction? So that slope makes sense. And look, if you were to graph a y-intercept up here by plugging in 0, well, we started at 930. We broke it, remember? So 0 is going to be really far away, actually. If we were to go by 10s, it'd be 920, 910, 900, 890, right? We don't want to play that game. But that's why we got such a huge value for our y-intercept. Does that make sense? All right, and then what did we get for R, which is called your correlation coefficient? It says R equals... That's okay. We'll just do 0.9897. So negative 0.9897. So what kind of correlation is that? Yes, it's negative. And is it strong? Yes. Why? It is strong since we said strong is any number between 0.7 and 1, right? Well, the absolute value of negative 0.9897 is greater than 0.7. So it's strong. Okay? So up here, I'm going to write strength, strong. There is a strong negative linear relationship. Okay? Everybody good so far? Yeah? Okay. And don't forget, to get R, you have to hit second 0, which is your catalog, and then turn your diagnostic on. Okay? Okay, so now we're going to perform the appropriate significance test for this data. Do you have evidence that there is an association between pressure and wind speed? Well, remember, I had it like this. You don't have to redraw this. This is just to help us out. We had pressure as our X, right? So we said as the pressure changes in millibars, the wind speed changes in miles per hour. Remember? So this was my wind speed going like this. I'm so visual. It just helps my brain to see, oh yeah, X is pressure, Y is wind speed, which means that the wind speed is dependent on the pressure, okay? Or explanatory. It's the explanatory and the response variable. So this is the explanatory variable. And this is the one that responds to it. So this is a response variable. Okay? All right, so to perform the test, make sure you write small, y'all. That's why I left all this page blank, because we got to write a lot, okay?
Like the last time, I thought we got away from that.
We did not get away from it. No, I'm sorry.
Never get away from it.
We're never going to get away from it. This is true. Okay, so the null is always the same for linear regression t-test. It's always beta equals 0, which means there is no association between the two, okay? And then the alternate, I'm going to look at the data. I got that it was a strong negative relationship, right? So I'm going to make this beta. How do I say it's negative? How does that compare to 0? Less than, yep. So I chose this because of R, okay? You don't have to write that. I'm just telling you how I came up with that, okay? So I chose that because of R. Because R was a strong negative, I'm going to go ahead and make the alternate betas less than 0, negative, okay? All right, the next thing we're going to do is check the conditions. The first condition is that it has to be random. The second condition is that it has to be linear, which I already said, yes, it is, because of the scatter plot, right? And then the third one, we have to make sure that the residual plot is scattered. Okay? So I'm going to show you how to do that. Okay. So while your data is in your calculator, click that so it'll save. While the data is still in the calculator, okay, we are going to go back to second y equals. I lied. Sorry. Struggle bus. I'm eventually going to get off. Or not. But hopefully, yes. Just kidding. We're going to go to stat, okay? And because I ran the test to get my linear equation, I will have residuals. Let me say that one more time. You have to get the linear equation first Otherwise, there are no residuals in your calculator, okay? So make sure you follow this process of getting that linear equation, finding your R value, because if you do all that, they'll be here. If you try to skip ahead and do this step first, it's not going to be there, okay? All right, so when you're in edit, hit enter. We're going to arrow over and up to highlight L3. Does everybody see that? And then we're going to click second stat. And it shows you in L1, you've got all those values. And L2, you've got all those values. I'm going to arrow down to option 7. It should be option 7 on yours. It might be option 8. But do you see how it says resid? So those are residuals, okay? I'm going to click enter, and I'm going to click it again. And it's going to put them in L3. Does everybody see that? Now, if you have not ran the linear equation to get the line and the R value, there will be no option for residuals. It's just not even there. There's no option 7. Okay? So you've got to do that first. Once you have these, now we're going to go to second y equals. And down here for my y list, I'm going to change that to L3. So the way we change it to L3, second 3. Okay? Nothing else changes. So still the same type, which looks like a scatter plot. The first option, okay? But instead of L2, we're going to change it to L3. You still leave your X's alone, though, okay? And then, how did we look at our scatter plot a while ago? We did zoom 9. Because look, zoom 9 says what? Stat. It's the statistics graph, so zoom stat. Okay, so that's why we do zoom 9. Hit enter. I don't know. Zoom 0, the first one?
No, at the bottom, under that.
I don't know. Let me look. Oh, my word. I should have went the other way. Zoom fit. Oh, it'll just zoom it in. So, a lot of times algebra or calculus, pre-calc, you can use zoom fit. It'll find the graph for you and fit the screen to it. And then you can look at the window to see what that is. Make it a little bit bigger if you needed to. That's nice because sometimes you keep zooming it out from the standard one, which goes from -10 to +10 on both axes. And you're like, where is the graph? You can't find it. So if you do zoom fit, it'll find it for you. And then you can look at the window to see where that is. All right. So we did zoom 9. And that is called a residual plot, okay? So I don't know if you can really see it, but they're right here. There's a couple below right there. See that? And then here's the next one. And then over here we have one right here, then one right there, and then one right there. So what you're looking for is to make sure that they don't make a pattern. We don't want them to be in a line. We just want them to be scattered above and below, okay? So now we're going to go back to our note sheet, and we're going to actually draw that in, okay? So I had a couple residuals over here, like this, and they don't have to be perfect. I just want to make sure you look at it. And then we had a couple like this. So is the residual plot scattered? Yes.
What does it mean if it's not scattered?
It doesn't satisfy the condition if it's not scattered.
You say that it technically kind of isn't scattered because those four, they technically form a line if you think about it, and then you have two on the other side that don't do anything. You're saying that
In all honesty, this wouldn't be a good data set because look how many data points we have. 6. We'd want way more. So if you had way more, it would probably be a better representation for the scattered.
So we're just doing this for convenience.
This is convenience, yes.
Isn't that a bad sample?
I didn't say it was a convenient sample. It's just a convenient problem because it's quicker. Okay. Y'all are keeping me on my toes today.
you have this like on a test or quiz and we got that kind of residual plot.
Mhm.
Would you want us to put yes?
Yeah, this is scattered. It's not in a line or a pattern.
It kind of looks like a line to me.
It's not a line because you have these over here too.
It looks like two lines. It looks like one big line and one.
Don't overthink it. Oh, thank you. Oh, gracious. Thank you. Okay. The last condition, random.
Oh, I was like, the last condition.
Yeah.
Okay, yes.
I kind of skipped ahead. I apologize.
Yes. And I'm in the problem.
It's stated.
Yes, it's stated. Now, last year, Miss Whitaker didn't have you check that first one. But this year, when I was researching these type of problems, it had it on a lot of them. So I included it. Which randomness is good, right? Because it removes bias from your data. So if you cannot satisfy this, I do want you to continue on with it. But just write, no, so data may be biased. And then yes, that's one of your limitations. Yep. Okay. So now that we've checked the conditions, we can run the test. All right. So you're going to have stat, calc, and it is option F, which is a linear regression t-test. Okay. So where are your x's? Your x's are in L1. Okay, so make sure it says L1. And then your y's are in L2. Don't get caught up on the residuals. You only use L3 for the third condition. Nothing else, okay? And then, what symbol is in your alternate? Because that's what goes here. Look at my alternate. I chose less than. Good. And then you run the test. It's going to give you a test statistic and a p-value. I'm going to put the p-value over here so I have room to interpret it. Yes? No, not calc. Test. I'm sorry.
Oh, you left that part out.
Stat, not calc. Stat test. Sorry. We calculated the linear regression time a while ago. I'm so sorry.
I know, I went to go find it.
You're like, it's not there. Yeah, let me give you a shout out. I'm sorry. I like that you're right with me and paying such good attention.
No, because
but I
if
said the
you're
wrong thing.
saying it, I want to do it so I know, because sometimes it's different on calculators. So I just
Yeah,
wanna be
and
sure.
I don't know why, because truly, those are all the same type of calculator. So I don't know. It's very weird.
I wanted to be sure when I did it that I had it right.
Sorry. Okay. Thanks for letting them borrow the whiteout. Sorry about that.
Alright.
You all need some.
You all needed it. I know. I'm sorry. I failed you.
No.
Okay.
We just trust you so much we went along with it.
Well, I'm sorry. When we did this up here to get to this, come on. To get that, why is it not working? That's stat calc, right? So that's why I'm kind of caught up in that. I'm sorry.
We know you mean no harm.
I do not. Oh, gracious. Okay. So now that you did stat test, option F, could you get the test statistic?
Yes.
Yes. What is it?
Negative
-13.85, which is crazy. Okay. So this test statistic is a little bit different from previous test statistics. Okay. It is a t-value though. All right. So when you get a value, it is on the normal curve and it standardizes. That would be t is 0. Okay. So if you get negative 13.85, look how far away that is. Does that look like it's less than 0? Yeah. We're going to reject that null that it equals 0. That's what that's telling us. Okay. So now I just have to interpret it. Okay. So if you get a number that's really far away from 0, that would be if there is no association. Okay. So because this number is so far away, I'm able to prove what's in my alternate. Okay. So the absolute value of negative 13.85 equals 13.85, which is large and far from 0. Which suggests a significant linear relationship between, now you just look at your x and y. What do we put on our x-axis? Pressure. So between pressure and wind speed. Very nice. So if you get a number close to 0, is there a strong or significant relationship between them? No, you might want to rethink it. You're probably going to get fail to reject the null. Okay? Does that test statistic interpretation make sense to you? Because if there is no association, which is what this is saying, then we're going to get a test statistic which is close to 0. Okay? So that's why this is 0. It puts it on the normal curve, and then we can see how far away it is from it. So if there's no association, we're going to get a number really close to 0. If there is an association, look, we got a negative number, which is what I was trying to show, that there's a negative relationship, right? As x increases, y is decreasing. Look at your scatter plot. As x increases, look what's happening to my y's. They're going down. I got a really far away value for my t, right? I got a really super big negative number. That's why we say absolute value.
When will we have it as not equal to?
The only time really to show that it's not equal to is if when you put your points on a scatter plot, you can't really see a strong relationship. Like it might look positive, but they're still really scattered. So you might just want to do beta not equal to 0. And then just show there is an association. But you can't really for sure say it's positive or negative. You get just weird scatter. You see what I'm saying? Like the points are just, you can't see a pattern like a line. They just kind of look all over the place. That's when I just make beta not equal to 0. And then a lot of times your R value is super weak because you can't even see the relationship. You know what I mean? Good question. Y'all good? Okay, so we interpreted our test statistic. Now let's write our p-value. So for p-value, your calculator would have given you 7.872046 E negative 5. That's called scientific notation, right? When E is negative, it's a tiny number. When E is positive, it's a big number, okay? And that makes sense because p-values are probabilities. Probabilities are always between what two numbers? 0 and 1. So 7.87 makes no sense, okay? But it does when I see that E to the negative 5th because that tells me I have to move this to the left 5 times. So 1, 2, 3, 4, 5, which means I have to put 1, 2, 3, 4 zeros. So my p-value is actually 0.1234787. That's a tiny p-value, which I'm not shocked. Look at this test statistic, how far from 0 it is. So the probability that's less, right? Yeah, I'm getting a tiny p-value. Okay, so 0.0000787. Okay, remember, this is how we interpret the p-value. If the null is true, so if, look at my null, right there. I don't know why I'm scrolling. Look at my null. If there is no association, so if there is no association between pressure and wind speed, then there is, I mean, what would that number be if we turned it into a percent? So basically 0, right? So then there is a 0% chance I what?
Got this by random chance.
I got these results by random chance. Yep. And what are my results? I'm going to get my alternate, right? Which is negative slope. So as pressure increases, wind speed decreases. Okay? All right. So now let's use our p-value. So 1, 2, 3, 4, 7, 8, 7. Compared to alpha. What do you want to use for alpha? 0.05. That's the most commonly used. You know, in medicine, life or death situations, we try to use 0.01 to be more confident in our results. But for this, it's just talking about wind speed and pressure. Okay. That is less than. So if the P is low, reject the null. So if you reject, yes?
Never mind, I had a brain fart.
Okay.
It'll come back to me eventually.
Okay. All right. So if we reject, is there evidence or is there not evidence? There is evidence. So there is significant evidence at the 0.05 level of significance to conclude that there is a, look at my alternate, a negative association between pressure and wind speed. So what does that mean?
That as the wind speed goes up, the pressure goes down.
Yeah, I always think of it, the x's. You said it right. I just think of it, talk about the x's first. So as the pressure, yeah, let's write, since this is the part that helps people in the audience on SRP, okay? Because if you say, oh, there's a negative association, they're sitting there like, okay, which means what, right? So, which means as pressure increases, what's happening to your Y's? Wind speed decreases. Okay? That's what the negative association means. All right. And before you get upset with me, because we have even more to write with these type of tests, I want to remind you, did I create statistics? No, I just teach it, okay? I just teach it. So don't get upset with me when we explain this next piece, okay? I know. This is my third time writing it. So just remember that, all right? It is important though, okay? So once you show there's an association, you can interpret what that line of best fit is saying, okay? And that's what the linear equation is. So I'm going to write it again because I have to see it. That's just how my brain works. It was 1496.7846 minus 1.4427x, okay? So if I want to interpret the slope, let's interpret the slope. Where is the slope?
with the X.
It is with the X. Good job. Right there. Okay? So what is that saying? That is saying for every additional increase in pressure in millibars, there is an average decrease in wind speed of, and now look at it, 1.44. Just pull that number, 1.44 miles per hour. So I just pull that number from my slope, and I'd said decrease. Why? Because it's negative. If it had been positive, I would have said an average increase. Okay? All right, so that's your slope interpretation. Now let's write our y-intercept interpretation, which sometimes the y-intercept interpretation just makes me laugh. Not on this one. This one it makes sense. But the next example I'm going to go over with you, it's just ridiculous.
Are you writing anything else after this?
We're going to put the...
Besides the confidence.
No, confidence interval, I need to move this down here because you don't need as much space for it. So that's a note for myself next year. And then the confidence interval.
Okay.
Uh-huh.
Make sure enough space.
I told you to write small. I did. In my defense, I said write small. All right, here's my y-intercept, everybody. Here's my y-intercept. So y-intercept is what? Where it crosses the y-axis, which means your x value is 0. So when pressure is 0 millibars, I would predict that the wind speed will be what? When x is 0, y will be what? Yep, 1,496.78 miles per hour. Let us pray that does not happen, because that would rip everything to shreds. Yes. There would be no nothing if the wind speed got to that. Tropical cyclones are real. They actually do happen, okay? But yeah, we definitely do not want the wind speed to be that high. So let's hope the pressure never drops to 0, because that would be really scary. Okay? Understand how to interpret that?
If the pressure was 0, would it what would it do to us?
To people?
Yes.
I'm not sure. I mean, it
So
would
if
cause
it's really
that.
high pressure, if it's really high pressure, wouldn't it be really difficult to breathe? So if it's really low pressure, would it also be difficult to breathe?
I would assume so, but I did not study this when I did science stuff. Or if I did, it was a long time ago. I'm sorry.
When does it? No, it doesn't.
It doesn't.
Pressure is
I don't
not
think it's
ever
hit
0.
in the history of the Earth. Ever.
Yeah, no, that would be catastrophic. Okay, so confidence interval, now we can run that. So while your data is still on your calculator, oop, that's not what I meant to hit. While your data is still on your calculator, okay, you go to stat, arrow over to test, not messing that up again, and we're going to choose option G instead of F. So see, F was linear regression t-test. We're going to choose the next one, which is linear regression t-interval, and hit enter. It is in L1, it is in L2, and we want to be how confident? 95. So I'm going to leave that alone, and then I'm going to calculate. Why didn't it give it to me? Oh, there it is. You see it in the corner over there. This calculator is so weird, but it was a free option, so there you go. This is what we get. All right, so see my interval? It says negative 1.731835 to negative 1.153519. Okay? So back to this. So I wrote negative 1.732 to negative 1.154. And then I also had written stat, arrow over to test, choose option G, which is linear regression T interval. And then my data was in L1, L2, and I want to be 95% confident. Okay? So what does that mean? Well, they're negative. Haven't I been proving everything's negative? So is 0 present in that interval? No, it's negative, which shows, this just shows even further that I'm right? So I am 95% confident that as pressure increases, wind speed does what? Decreases. Good. Wind speed decreases between 1.154 and 1.732 miles per hour. You'll notice I did flip those because we always put the smaller number first. So when you read it, it's negative, so that's why the bigger number's listed first. But when we write about it, we put the smaller number first because we put decreases, okay? So it's going to decrease between 1.154 and 1.732 miles per hour, okay? So does that confirm my hypothesis test results? Yes. And you don't necessarily have to write this. I am going to write it for the third time. Just so that it helps you remember, okay? So look at what's in the null. If there's no association, then beta equals 0. Then I said beta is less than 0. Look at your results. Is 0 present? No. Is beta less than 0? Yeah, look, this is negative and this is negative. So since 0 is not in this interval, there is significant evidence of a negative linear relationship. Woo! Good job.
We don't hate you, we hate the math.
I know. It's a lot of writing. I know it is. We didn't always do all the writing, but then second semester, when it's time for people to explain what stuff means, that was a challenge, right? So my job is to teach you along the way so that when we get to the spring semester, you'll be like, I've been doing this so long. Okay, I got it. Okay?
So will we use every unit we learn in our project?
No. The beautiful thing is you're only going to run one test for your SRP. And then for my projects, you're only going to run one test. You're not going to have to do all of them, which would be super overwhelming. You know what I mean? And truly, in all the years I've been teaching at Gov, I've only ever seen one student that had a linear regression t-test. One. They did like grip strength and the length of your pinky or something, or grip strength and the length of your index finger. I don't remember. Something. They measured, well, both of those measurements was quantitative, so they had to do a linear regression t-test. But we've had some, very few, but we've had a couple do chi-squared, right? Because that's qualitative data. But usually it's a test of means either one sample t-test or a two sample t-test, or we've had people that have paired data. So you find the differences, you measure the differences between your before and after, and then they still ran a one sample t-test. And here in the past few years, we've had several do a NOVA. A NOVA is because you have 3 or more groups and you want to see that average. How do the averages compare? But yeah, this is not super common. Still important to teach you though, because there is quantitative data when you're looking at the relationship between two quantitative data sets, right?
What's the most common test that people
T-test. Yeah. Sometimes people have a 1 prop Z or a 2 prop Z, like they're comparing two proportions. Yes, of course. Thanks for asking. Okay. I did want to give you a more formal definition. So an influential point I told you the way I think about it is it's like an outlier. Well, this definition says an influential point is an observation that has a disproportionate impact on the results of a regression analysis. So we're looking for that linear regression, okay? In a scatter plot, influential points are those that are further away from the regression line. So again, they are further away from our regression line than the rest of the points. And they can have extreme X or Y values, or they could just be distant from the rest of the data without having extreme values. The main thing is they're really far away. If you were to put a line in there, either like that or like that, an influential point, you might have stuff like this, right? That's kind of going all around, and then have something way up there. Because if I have something way up there, what's that going to do to my line? It's going to pull it like that, right? So if I remove that point, that influential point, it's going to put that line back down here with the rest of the data. Does that make sense? So influential points really do have an impact on that data. They pull it, okay? All right, let me get rid of all my scribbles. I'm so visual, though, that it just helps me when I can visualize it. All right, here's another example. If you're predicting house prices, let the explanatory variable, which one's explanatory, X or Y? X, okay? X is the explanatory, and then the response variable is Y. It responds to it, okay? In Algebra 1, pre-algebra, you would have learned to call them independent variable, dependent variable, okay? So Y depends on X, so it's responding to it. Okay, that's how I remember it. All right, so let the explanatory variable be the size of the house in thousands of square feet, and let the response variable be the price of the house in thousands of dollars. Does that make sense to you, why we would let X be the house size and Y be the price? Do you think the price depends on the house size? Typically, yes. Okay, use the following data to run the appropriate significance test. So here's our sizes right here. And they look weird, but remember, that's in thousands of feet. Okay? So if I get a 1, that's 1,000 square feet. Does that make sense? So that would be 900 square feet, 800 square feet, 1,100 square feet. That's how you interpret this. Okay? So these houses are actually 3,500 square feet. And look at how much they cost. It says $172,000, which we know that has changed drastically over the past several years. Houses cost way more than that, if they're that big. Okay, so we're going to put size. That's going to be which one? X or Y? X. So these are going in my L1, and then price is my Y, because it depends on the size. The price depends on the size, and I'm going to put that in L2. Okay? And then what's your acronym to help you remember what descriptive statistics to use? LIDS. L-I-D-S, which stands for linear, influential points, direction, thank you, and strength. And remember, to get this, to get the strength, what do you have to do first? The R thing. How do you get the R thing, though?
Actually runs this.
Run the linear regression equation. Okay, so you actually have to do this first. Otherwise, you're not going to have R. Okay? So on this one, I'm not going to make you draw the scatter plot. So for me, when I looked to see if it was linear, I did just sketch it in, but I didn't make it perfect like the previous one where we actually broke it into increments on the X and the Y and then drew it perfect. So you don't have to do that, okay? So go ahead and put your data and your X's and your Y's, okay? And then look at the scatter plot. Just put it as 70. It's fine. Remember, as long as all of them are the same, you don't have to put 70,000. You can just put 70. So you can literally enter it that way. Are there 15 data sets? Let's look. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep. Okay, is it linear? Yeah, so I just sketched it in for myself. It kind of looked like this. It's kind of points.
Wait, Miss Harold,
Mm-hmm.
I didn't do that part, but after I looked at the R value.
Ah, so you use the R value to do it. Interesting. That's fine. So just somehow let me know that, okay? So the R value is what?
That's 0.2, 0.9. No, not 0.9092.
Mm-hmm. Yeah, since R is 0.9092, that's a strong linear relationship, right? Direction. R is positive or negative, or if I look at the scatter plot, yeah, the direction is positive. And did you think you have any influential points? So you do have to have the scatter plot for that, for the influential points. Any? Good job. She's shaking her head. No, they all appear to be close together, right, Bree? Mm-hmm. Okay. And I think down here, the next time I teach this, I'm going to get rid of this stuff. Like, because if you answer your lids, you've already told me the correlation coefficient, right? And you've already told me the type of correlation because you already answered the strength. Or, excuse me, the direction. And then you already told me it is strong. But the explain piece, why? 0.9092 is greater than 0.7. So that's why it's strong. Okay? So last thing I haven't written is your equation. So y equals a plus bx. I like to do it that way because slope, right? That's our test statistic slope. Not test statistic, good grief. Descriptive statistic is the slope, is b, and we write our parameter as beta. So that's like why I like to write it that way. Okay, did you get y equals 38.8847 plus 35.38596x? Yes. Yeah. Your calculator, when you do stat calc and choose option 4, it's ax plus b. So just make sure you pay attention. This is your slope. So when I write it, I actually put the a value it gives me right here with x. I know. It's okay. I'm not going to count it wrong if you write it this way. I'm not going to count it wrong. So if you want to do that, that's fine. Because it's all about interpreting the slope and the y-intercept, right? So as long as you understand the slope is with x, the y-intercept is y, you're good. Or not with x, rather. You know, it's the y-intercept. Let me ask you a question. Could you tell me if x was house size and I said the house size is 1.2, could you figure out the cost? Yeah, you just... Yeah, you got the line, so you just plug it in. This is called your prediction equation. Okay, the linear regression equation is also known as a prediction equation. As long as there's a strong relationship, you can feel pretty confident in those results, okay? So if I said x, let x equal 1.2, if you're looking right here, that would be somewhere right there, right? So I'm guessing my house is going to cost somewhere between. P.S. Some houses, depending on location, can cost more. People pay more in the city, right? Also, if it's in a historical district, that can change the price. So it could be a small house, but still cost more. So there are some confounding variables that could have an impact on the price. Don't be sorry. All right, so I'm just saying, if you let x be 1.2, you would just plug that into your prediction equation, okay? And because it has a strong correlation, I can feel confident in that prediction. If it had a weak correlation, I wouldn't feel very confident in my prediction. Okay? All right, so now it says perform the appropriate significance test for this data. Do you have evidence that there is an association between house size and price? So my null and my alternate. So null is always beta equals 0, which means there is no association, right? I write it in parentheses because it just helps my brain. So I'm going to choose on this one to say beta is what? What do you think? Do what? Greater than, yes. Because it looks like there is a positive association, right? And a positive association means as x increases, y increases. So as house size increases, price increases. Okay? All right. So the next thing we have to do is check our conditions, which some people call that criteria. Some people call that the assumptions. The first one is random. Is this random data? It was not stated, so I'm going to say no. So the data may be biased. And I'll include that as a limitation if I was presenting this.
Wait, so we don't have to do that whole thing where we have to do the CLT? So that's normal.
That's normal, right. So size doesn't make it be random. Because I could do a convenience sample, right? Which is a horrible sample and get 30, right? So randomness is good sampling method, which would be simple random sample, SRS, right? Stratified, cluster, systematic. Those were all examples of a good random sample. So somehow, either they have to tell me one of those 4, SRS, systematic, stratified, cluster, or they have to say that they took a random sample. Yeah. Okay, second one, linear. We already checked that, didn't we? Yes. Okay, and then the third one, the residual plot is scattered. Okay. So do you remember how to do that? Once you're in your data, you've already followed the order, so you should already have your linear regression calculated, right? So since you've calculated it, go to edit, go to stat edit, highlight L3, then do second stat and choose option 7, and then hit enter, and then they should be in L3. Okay.
It's scary.
It is scattered. I drew it in right here. I'm going to cheat. I'm sorry. I drew it right there. So you'll notice on this one, can you copy it somehow? Can I circle that and copy it in? Yes, thank you. Let me put this in y'all's. Beautiful. Thank you so much. Y'all, what am I doing? I don't know. Depends on the day. I want to paste. How do I paste it? That ain't what I want. Okay, well, I thought I could paste it.
Don't you have like a little mouse button?
A mouse?
Yeah, if you like pull up your thing, like a little like thicker letters.
I don't know.
No.
I could add a sticker.
Why don't you try that?
Add a sticker.
Yes. Like a sticky note, and then you can paste it on there.
I just want it to let me paste. It won't even let me paste. It's just let me select. All right, well, it doesn't matter.
That's no fun.
Yeah, sorry.
Oh well.
Let me go back over here. The whole point was for you to see. So draw it in so I can see. I'll try one more time.
Will it let you circle a different place and
I don't know.
It's being weird.
It is being weird.
I think it
Paste. Yes! You all are geniuses. I love it. Good job. Okay. Oh. There we go. So is it scattered? Yes. So I do want you to draw it in for me, okay? Y'all.
Please don't tell me it done the thing.
Please don't tell you it did the thing. It totally did the thing. Let's see. Because it's fun. It's a good day.
We figured it out. It's okay.
We figured it out.
Okay.
Yes. So it is scattered. Okay. So now we can actually run the test, right? So we're going to do stat, or over to test, not calc. And PS, remember, to get the residuals, I'm going to write it. You must find equation first. Remember, so as long as you do lids, right? As long as you do lids first, you'll be good. Okay? And you should find the lids first, because otherwise, how are you going to know what to put in your alternate, right? How do you know what to do, right? Magic. Math magic. I love math magic. All right, so stat test, it's option F, which is linear regression t-test. My x's are in L1, my y's are in L2, and I'm using what symbol? Greater than. Okay? So when you run the test, you get that t is equal to, yes, so if you think about that, if there is no association, that would be 0. Where is that test statistic compared to that? Way up here, right? So if there is no association, that'd be 0, or that'd be a number really close to 0. I got a really big number, right? So the positive test statistic suggests a positive relationship between house size and price, since 7.87 is far from 0, it is a significant relationship. Okay? We're kind of running out of time. P-value, I'll interpret that. So I'll make a video after classes today to finish this one for you, okay? So that you can do the practice problems, because next class, I'm going to give your quiz back. We'll go over it. We'll go over these practice problems if you have questions for me. And then I'll give you the test review, okay? So test review next class, and then the following class you'll have your test. All right? Questions for me?